The next scrap tire condition is air infiltration. The tubeless tire liner is a layer of butyl rubber bonded to the inside of the casing. The primary purpose of the inner liner is to be an envelope to hold the air in the tire. That in turn puts tension on the radial steel cables, which enables the tire to support the load. Air infiltration occurs when there is a damage to the inner liner, allowing the internal air pressure to travel within the steel and other rubber products, causing a separation. Air infiltration can be found in the tire's sidewall, bead area, and crown belt area. The primary causes to look for are nails, bolts, and debris perforating the tire, section or nail hole repair patches, cracking, splitting, or lifting. Tire bead and liner damage can be caused by improper tire mounting procedures. For example, the small cuts found on the inner liner caused by the use of the bill end of a tire hammer when mounting the first bead onto the wheel. Road hazard conditions, such as a radial split following an impact. And manufacturing conditions such as inner liner splice cracking. A pinch shock condition is the next effect discussed. This occurs when the tire is sandwiched between the wheel and a blunt object such as a curb. This damage can vary in magnitude, starting with a light crease in the steel sidewall cables. This is generally not a reason to scrap the tire. In a more severe case, the wheel can damage the guide rib and lower sidewall area. Look for wheel damage as well. In addition, there can be internal damage to the tire, such as a tearing of the rubber products between the carcass and crown plies, as well as the creation of a radial split condition. Both conditions, without careful inspection, could be overlooked and create a separation later in the tire's life. Pinch shock damages are primarily seen as trailer tire damage. However, all wheel positions on a vehicle have the potential to experience a pinch shock condition. As the length of trailers increase, so does the potential for this type of damage. Pinch shock conditions are often confused with guide rib or chafer separations. The way to distinguish between the two conditions is that pinch shock tends to be a localized damage, often accompanied by abrasions and cuts in the sidewall. Chafer separations tend to be more circumferential in nature and are associated with casing fatigue. An impact damage is the result of an impact with a sharp object under the dynamic conditions of speed, load, and pressure. You will generally see cuts in the rubber from the impacting object, as well as a clean severing of the individual steel cords at the point of injury. Emanating from the point of injury may be a rupturing of additional steel cords in the sidewall if the impact is very severe in nature. A fatigue damage, on the other hand, is a distortion or opening in the tire sidewall area generally caused by weakened body plies resulting from fatigue or oxidation of the steel. To distinguish between fatigue and impact, look closely at the body plies. In a fatigue rupture, the individual strands of one cable will be of different lengths. Comparing a close-up view of an impact versus a fatigue damage, we can see the different look of each tire condition. As with an impact damage, a fatigue damage can also rupture out from a weakened area. The most significant causes of this condition are damaged cords, resulting from the following: cuts in the crown or sidewall area, allowing moisture to reach the steel cables, bead damage, improper repairs, objects wedged between duals, and dual wheel run flat. This zipper rupture is a premature fatigue condition in a casing. What makes this condition serious is that it is generally created after the tire has been removed, improperly inspected, repaired, and re-aired up. A close look at the sidewall plies in a zipper rupture will reveal the uneven detachment of the cords within the sidewall, and the ends of the individual cables have a stretched appearance. Looking at the deflection of a flat tire on a loaded dual tire assembly will show how this condition is caused. Here is a view of both tires at 100 psi with normal deflection. Here, the inside tire has been reduced to 50 psi. Note the change in deflection. Finally, we have reduced the inside tire to 20 psi. This has created an extreme deflection in the inside tire's sidewall. An X-ray taken of this type of run-flat damage shows the individual broken sidewall cords. When improper tire inspection and tire mounting safety instructions are not followed by a fleet, potential injury could result. It is important to follow the recommended industry procedures when changing potential run-flat tires. Please refer to the RMA Tire Information Service Bulletin, March 1995, Volume 33, Number 2. The following are some additional tire conditions which occasionally appear in scrap piles. They will be presented in an effect and cause format. This is a tire which was rejected by a retreader for weather checking in the sidewall. The tire has been placed on a spreader with the beads extended, as it is done during initial inspection at a retread shop. Note the apparent increase in severity of the sidewall cracking. Here is a cross-section of a tire with a greater degree of weather checking. You will note that the depth of the cracking is superficial and should not affect the tire's retreadability. There are several sources in the industry for templates and scales which can be used to determine the degree and severity of tire weather checking. The next condition to discuss is bead damage due to brake heat or burned beads. This condition is caused by extreme heat created in the brake drums during frequent brake applications with little cool down. The condition can also be aggravated by over-adjusted brakes or mechanical problems with the vehicle braking systems. This tire has what appears to be a separation in the tread area. And this tire looks like it has a series of sidewall separations. Both are the result of rubber swelling caused by exposure to petrochemical products such as grease, oil, or diesel fuel. This is evident by a decrease in the hardness of the rubber and in many cases by an odor on the rubber itself. Understanding the reasons why tires are being scrapped is important in the protection of your investment and in lowering your overall tire cost. You should know what caused each of your tires to be taken out of service. Operating conditions, avoidable or unavoidable, require an understanding of all potential causes and resulting effects on the tire and the tire budget. This video has reviewed some of the most common causes for tire removal. The conditions were categorized in the following areas: run flat, air infiltration, pinch shock, impact damage, and fatigue damage. There are currently numerous methods in the industry for documentation and analysis of scrap tires. Your Michelin tire representative will be happy to assist you in the implementation of such a program in your operation. Remember, the obvious damage seen on scrap tires is possibly only the resulting effect. Understanding the cause is what is important to improving your tire maintenance program. Analysis of your scrap tires may also reveal some casings that may be returned to service in your operation. At Michelin, we want to provide solutions to help you lower your tire costs.
Michelin, a better way forward.